get started today. What we're going to be focused on is electric room layouts, and mostly the focus on Article 110.26 and what that means for your electric rooms, how that kind of affects your layouts, as well as also some recommendations or rules of thumb that kind of make your electric rooms a little bit easier to maneuver and work in when you're working on them. So first, we're going to start with all the NEC required clearances. And the first one we're going to start with is equipment working space, which is the width clearance. So when you get a panel or any piece of equipment, the minimum width that piece of equipment needs for its working space width-wise is 30 inches. As you can see, for a smaller branch panel, it's going to be a little bit larger than the panel itself. But when you get a larger distribution panel or larger equipment such as ATSs or switchgear, it's going to be the width of the equipment at minimum. So as you can see, this panel is 36 inches. That width of the working space needs to be the same width of the panel itself or the equipment. Next, these clearances can be measured from the edge of the equipment or from the center. So as you can see for this panel, you can measure 30 inches clear from the left side past the panel. This one you can measure from the center of the panel. It can even be offset a little bit. As long as there's 30 inches width-wise within sight that in front of that piece of equipment, you're clear. Unless that equipment is larger, as you can see here, these are still technically being measured from the edge. It can't be offset. So it has to be the same width of the panel for larger pieces of equipment. Moving down, clearances can overlap each other. So as you can see here, these panels are very tight together, grouped. But if we turn on their clearances, you can see that all these panels are overlapping and all sharing the same clearance space. So this allows you to actually create tighter configurations of panels instead of spreading them out. However, to make work a little bit easier for yourselves, you might want to consider spreading them out, but the options here. Little quiz here is if I have a panel side by side and I'm going to use the left edge of this panel to justify it, do I have enough clearance space for this panel? Answer for this one is going to be no, because the panel itself, this clearance, even if I justify it to the left all the way, let's go 6 inches. It's still going to be butting into the other panel itself. And you can see that we're actually into that panel, so this actually isn't clear enough. The easiest way is to check is to measure from the bigger piece of equipment to the wall to see if it is. If you run into a situation like this, it's not ideal, but you could always pull that panel forward. So now that the panel both share the same space, so now it's not obtruding into the panel itself. But it does leave you with a large gap in the back of this panel here. Awesome. So moving on, we're going to go on to the depth clearance of working spaces. And this one goes into variable conditions based on what is opposite of the panel as well as the voltage of the panel. So first we have condition 1, which is if there are no grounded parts in front of the panel, or no exposed or grounded parts in front of the panel, so that would be just open space. If there's condition 2 is if there's grounded parts in front of the panel. Grounded parts are usually considered brick walls, tiles, any type of wall in front of it with no electrical equipment. And then condition 3 is when you have exposed live parts to exposed live parts. That gives you the largest clearance that you need here. And that is all based on table 110.26A1 working space. The first is based on voltage, so your 208 volt panels live in row 1. Your 480 volt panels will live in row 2. And this is the definition of how far they need to be. So in this space here, we have 480 volt panels, and you can see that each one follows the condition based on what is in front of them. Either grounded parts, non-grounded parts, or exposed live parts. When you're also measuring exposed live parts, you're going to be measuring from the face of the equipment to the face of the equipment, not from the bus to the bus. Just so everyone's aware. So right now we also have a couple of instances here that work with depth. Is this transformer have enough clearance in front of this panel here? Is this transformer up to code? So the answer for this one is no, since it's a 480 volt transformer going to 208. It's going to need 48 inches of clearance in front of it so that this panel actually cannot live here. It has to move out of the way. Same thing with this panel. So this 48 volt panel is positioned here, and you want to install a 208 volt panel here. Do you have enough clearance with this 42 inches to install this panel here? Answer for this one is also no. Anytime that, even if there's a little bit kind of peeking into that clearance zone there, this panel is now live parts to live parts. You have to consider it as 48 inches. So this panel cannot live here. You'd have to move this panel over so you can reduce the width, reduce the depth of the clearance, or you would have to move this panel further down away from it. Awesome. And then one of the other things that you have to consider is going to be the door swing as well as the egress. So this is one that is usually missed a lot, but you would have to, let me turn off the clearance here. Consider the door swing. If there is a door on the panel that swings open, you can have to maintain at least 24 inches of egress so that a person can pass this panel if this door was open, for instance, that they can pass through it. This right here, if it is a door that swings all the way open 180 degrees and you do not have that 24 inches of clearance, this would be a code violation. If the panel door swings the other way, for instance, this would be no problem, as the door is not even going to be hindering the exit way. But however, this one still would interrupt that path of egress. So just be considerate of your doors and try to stay away from the door as much as possible and the path of egress. Moving on to the height of the working space. The height of the working space, I'm actually going to jump back over here, needs to be at least 6'6" minimum, or the height of the equipment, whichever is larger. So for your 90-inch panels here, it's going to be much higher from the top, and that should extend from the top, from the top of the equipment all the way down to the floor, or that 6'6" all the way down to the floor. You can also have electrical equipment and housekeeping pads extend 6 inches into that working zone if you need to, but 6 inches is max. If you have anything further than that, say if this is housekeeping pad is 7 inches or even further, that would be against code and you might get called out on it. Same thing with the trough, is if you went into a larger trough size, not 12 by 12, but if you went to like 18 by 18 for whatever reason, that would be sticking too far into the working space clearance. And then lastly, we're going to talk about the dedicated electrical space. So this is the space that lives from the panel underneath it all the way up to 6 feet above the panel itself. and that's the dedicated electrical space. And what this is saying is that if something lives within that space, it has to be electrical in nature or an electrical installation. For instance, if this trough is here, this is okay as long as it doesn't stick out that 6 inches into the working space. But this plumbing line that lives within that 6 feet above the panel, this is a code violation. So this plumbing pipe would have to move, or you would have to move. This duct up here, is this a code violation based on Article 110.26? So based on the code, this foreign system is above the 6'6" space. So it is permitted to live there, so that duct can stay there, but a drip pan has to be installed underneath it. And most cases, whenever we're dealing with this, we want to avoid this in all forms or fashion. The reason why is that drip pan hasn't been accounted for. We don't know who is have to provide it. The inspector usually doesn't want to see a drip pan because why would a new building need it if we're installing it? If you're in a existing building and there's really no way around it, that's way you can get around code. But for more or less, if you're doing a new installation, you want to avoid going or having your equipment being under any other equipment other than electrical. And then lastly, when we're dealing with dedicated electrical space, you can have structural elements, or sorry, structural ceilings above it, but you cannot have any other foreign elements in that space. So for instance, this ACT ceiling, because of 110.26E1D, this is allowed to be here as a removable ACT ceiling. It does not count as a structural ceiling, however. However, this slab up above does. This piece of beam here, generally for the most part, this beam would be a code violation with your panel being underneath it because it intrudes in that 6 feet space. Most inspectors don't seem to have an issue with it, but just be aware that they could call you out on it. It's because it's calling for the structural ceiling, not a actual structural element. And again, just for reference, the working space is the space in front of the equipment. The dedicated space is from the floor of the equipment to 6 feet above the equipment. Does anyone have any questions about Articles 110 and how they kind of affect the layout of the electric room? Awesome. All right, so let's go over some spacing layout recommendations from all the times that I've been laying out some equipment. So a good rule of thumb is that when you're laying out panels, you should have 6 inches between panels. This is the recommended spacing to give you enough room to run pipes up and down the side of it, give you enough working space with your hands to actually get next to the panel. If you do have to make panels tight, 2 inches minimum is what's recommended. That's what a lot of the foremen that we have in the field work with. So 2 inches should be your spacing. And then if you're going to be placing a panel next to a wall and you want to leave future space, you want to leave 8 inches of space between the wall and that panel that you're installing. That allows a future branch panel or smaller distribution panel to be installed in the future. When we're working with transformers, there's a couple of different things you want to maintain. When you're dealing with 2-inch or smaller secondaries, you want to have your spacing of 6 inches between your primary and your transformer, as well as your secondary and your transformer. This allows you to work with the fittings as well as keep the copper length down. It also provides a nice, clean, symmetrical look. However, when you're dealing with larger secondaries, such as I think it's 400 amp or over, you want to deal 2.5-inch or larger secondaries. You want to increase your spacing from your 208 panel and your transformer to 8 inches. The reason why is this allows you to use those larger 3-inch connectors. That'll probably bump out to about 6 inches here when all is said and done, and give you a nice straight path to your transformer here. If you did that over here with the 6-inch one, you're going to be probably running up to the backside of the transformer here, and it's going to be a lot harder to get that connector in. When you're laying out your electric rooms and you don't have the specifications for the transformer or don't know the manufacturer specs, you should plan for 6 inches of space behind your transformer. And then when you actually get the specifications or the submittal from the manufacturer, right on the transformer, I would say boilerplate here, it will tell you exactly the spacing that you'll need on that transformer. So for instance, this is a transformer from the Novo job. It is calling out for 5 inches of space between any adjacent wall. So you would then update your design to capture the manufacturer's design for the install. A lot of the transformers I see nowadays are actually going down to even 2 inches or even less. So it's also worth looking at the transformer spacing recommendations so that you might be able to save some space in your electric room. Last thing I want to cover is how to place kind of corner transformers. What we want to do is, since the secondary is going to be a larger wire size and gauge, it's going to obviously cost a lot more if we're running it long. So what we want to do is try to keep that distance as short as possible. So we always want to place the 480 volt panel where it has further of a lead, because that is going to be it's going to be a smaller wire gauge, which would then lead to less copper being purchased and installed. So this would allow you to actually create a cheaper installation versus if you installed it. Where this one was the 480 volt panel, and this was the 208 volt panel. If you're stuck in a tight spot, this is not really going to be the end of the world, but it is a little bit of a help on the install and the pricing of the gear. So try to work it if you can with the panel or the 208 volt panel closer than the 480 volt panel. All right, if no one has any more questions, thank you guys for watching and have a good rest of your day.